Hi, welcome to our parallel session entitled Building Tactile Graphics Literacy, Findings and Implications from Two Studies. I'm Dr. Kim Zebahazy at the University of British Columbia.
Hi, I'm Dr. Penny Rosenblum at the American Foundation for the Blind.
We wanted to begin our session by sharing with you the model of graphic interpretation that came out initially from survey research done with teachers and students, and is being further validated with the studies that we're sharing with you today. And basically what this graphic shows is that effective interpretation of graphics, such as tactile graphics, is dependent on the interrelation between these components: content, knowledge, and experience that the student has, their confidence and their motivation in using graphics, the quality of the graphic itself, such as how it's produced, and then the strategies that they engage while looking at graphics to extract information. And in the strategies category, particularly with tactile readers, that breaks down into their technical skills as well as their thinking skills. And technical skills can be things like their hand movements, for example. In this presentation, the two studies that we're going to show you focus mostly on looking at the strategies and how to promote students learning better strategies. The two studies include study one, being investigating graphics and reading strategies, conducted at the University of British Columbia. There were 20 tactile readers who engaged with tactile graphics to answer multiple choice questions, and that included a bar graph, a Venn diagram, a rotation item, a geometry item, and a map. They did a think aloud protocol, which meant that they talked out loud what they were thinking and doing as they were doing it. And we video record them doing this, including the movements of their hands. We analyzed the transcripts and the videos for performance, strategy use, and their hand movement techniques. In study two, which was conducted at the University of Florida in conjunction with the University of Arizona, the Animal Watch VI Building Graphics Literacy Project had 33 tactile readers involved. And they developed a curriculum that was used via an iPad app, a teacher guide, and tactile graphics to teach students the strategies to engage with different graphic types. A pre and post test was used to look at what was learned, and for any of the students who finished at least 8 of the 10 units in the curriculum. And teacher and student interviews were also conducted. The Animal Watch VI Building Graphics Literacy project was funded by the Institute of Education Sciences in the United States, and it was awarded to Dr. Carol Beal at the University of Florida, with the subaward to the University of Arizona, and ran from July 1st, 2016 to December 31st, 2019. And the Lighthouse for the Blind and Visually Impaired was employed as a partner in making the tactile graphics for the project. The project goals for both of these studies included, in study one, learning what strategies and thinking skills students with VI employ when engaging the graphics, so getting an understanding of what they're actually doing, and then looking at the highest performers and extracting out their strategies and hand movement techniques so that we could learn about ways that we could teach students that were struggling more to improve their efficiency. And in study two, the goals were to support students at the pre-algebra level in building their efficiency and accuracy in gathering information from material presented in the graphs and maps, and to provide teachers of the visually impaired strategies and techniques they could use to work with their students in developing this accuracy and efficiency. The information we learned from study one, as well as previous survey studies, filtered into study two in terms of how we looked at and designed the curriculum. It was one of the components of information we used as we designed the curriculum. From study one, the think aloud and hand movements of a higher performer, I'm going to show you a video in just a minute. What you see on the screen right now is a breakdown of just one component of our analysis of hand movements. So we looked at the videos, and step by step, we wrote down every single thing the student did with their hands to answer a question. So this is a breakdown of the student that you're about to see and what they were doing with their hands to answer a bar graph question. So that they use both hands first to read the question using the scissor method, and then both hands return to the bottom of the bar graph to check it out. The left hand then stayed at the beginning of the x-axis while the right hand traced the x-axis line. After rereading the question using the right hand, they decided to check the bars instead of the x-axis. The right and left index fingers were close together, checking the first two bars from bottom to top. The right index finger checks the rest of the bars by touching the middle. The right hand checks the top of the second bar and the left hand checks its value on the y-axis. And then the left hand stays on the second bar and the right hand traces down to check its label on the x-axis. So as you can see, this student who is higher performer did different things with their hands at different times, depending on the task that they were doing to extract information from the graph. And we're going to watch that right now.
Double bar graph compares TV sales made by Sam Thompson during selected months of 2 consecutive years. Use the graph to answer questions 1 through 3. Okay. During what month of the year were Sam Thompson's sales the highest? So I see that it's a bar graph. So what I'll do is I'll look at the bottom and it's the list of the months. So I'll follow them up and it says during what month. Okay, so I'll look at the bars and see which one is the longest. And it looks like the second one in from the left is the longest. So I'll follow that over to 70. But the month is April. So that would be April, and then the years. So, oh, I might want to look at that. The key is the smoother bar for year 1. So the longest is the smooth bar. So it would be year 1. April of year 1 is answer D.
Okay, and so she moved back and forth between the question and the graphic, and then she used her hands, as we discussed previously, in various ways to get that correct answer.
All right, let's talk about study 2. So we developed a curriculum that had 10 units, 2 about bar graphs, 1 for line graphs, 1 for circle graphs, 1 for Venn diagrams. We had 2 coordinate planes. The first one focused on quadrant 1 and the second one on all 4 quadrants, box plots, maps, and data tables. So the students did these 10 units using the accessible iPad app, the teacher curriculum. Each unit had 4 graphics, and those actually are now available for sale through the Lighthouse. The app is available for free from the American Printing House for the Blind. When you buy the graphics, you can buy a print set, a UEB set, or a Nemeth code within UEB. And I think it's important for you to know that each unit has an animal that it's focused on, and the content about that animal is authentic science data about endangered or invasive species in Australia or Africa. So we'll go on to the next slide, and we're going to talk about how the units are structured. So the student gets some information about meeting the animal, including the sound the animal makes, which is motivating to many of the students. Then we have 2 getting started questions. The student uses sheet 1, and they're asked 2 open-ended questions to describe what they're seeing and to explain the data. Then they move through 10 warm-up problems. And so for this, they continue to use sheet 1 for some of the problems, and we introduce sheet 2 for some of the problems so that they're seeing 2 different kinds of graphics in that same category. And the focus of the warm-up is to help the students learn the concepts that they need. So for example, with line graphs, understanding the X and Y axis, how to find a point, how to verify that point, how to estimate between 2 lines. Then after they do the warm-up, they move on to the next part of the unit, which is where they select the level of difficulty they want. And this will then give them certain problems in the unit. So based on how confident they're feeling with the content. So they then move into set A, which is the application, and then after that set B. And both set A and B start out with 4 multiple choice questions where they locate information. So similar to the warm-up questions, but now we're not guiding them. Then they have 1 math question where they need to find 2 numbers on the graphic and then use those for a simple math problem. And then finally, they have a prediction question where they have to really think through, what does this data mean? We have them check in at the end, which is like the select difficulty on how difficult they thought the information is, and then they do an open-ended what I learned before reading the conclusion. So I want to show you an example of a Braille reader who's using a refreshable Braille display, and I'll be narrating the video, but she's also good about reading aloud. So we're going to see her working with a Venn diagram that has 3 circles. First, she's going to do a multiple choice question, and then she's going to do an open-ended question. So let's watch the video. Let's go ahead and watch a student who uses a refreshable Braille display paired with her iPad.
She reads the problems aloud.
Problem A5. How many students in all visited the platypus exhibit? The Tasmanian devil exhibit, or both?
She's looking at the numbers in the Roar and Snore campground. Now moving up to the circle for the platypus exhibit, reading those numbers and using the fingers on her right hand to do some adding. She's looking at the intersection and the numbers there, adding those with her fingers. And she's continuing to add numbers. Now she is in the Tasmanian devil exhibit, has read the numbers, adding more numbers on her fingers, looking at the intersection, and going back to her Braille display.
$147.
Correct answer.
Problem A6. Imagine that the zoo stops offering the Roar and Snore campground option. How will the Venn diagram change? What will it look like? Record your answer.
She takes a quick check of the Venn diagram and then returns to her Braille display.
There would be less students that went on the field trip, and there would only be 2 circles that overlapped, not 3.
So as you can see from this video, the student really did some problem solving to think about how the information would change. I'd like to move into now talking about implications from both studies 1 and studies 2. So we want you to think about 6 different concepts: systematic approach, previewing, differentiated hand movements, verifying information, using surrounding information, and vocabulary development. And we're going to talk about each of these 6 concepts that really underlie efficient graphics literacy. So our first one is systematic approach. And this is where our student needs to make a plan and understand really the whole page, what's on that graphic, having knowledge of those parts and how they fit together. And the student really needs to understand, how do I approach? Am I the type of person who benefits from a top-down approach? Is it more efficient for me to find something in the center and use that as my reference point and move out? It really depends on what is most comfortable for that student and is going to allow them to be efficient. So you don't want to dictate to your students, but you want to encourage them to be systematic. Now, our second point, before I get to that, I want to make sure I share some great quotes with you. So these are from our second study, the Animal Watch study. And a teacher of visually impaired student shared, at the beginning of the study, I'd have to remind her to take her time and examine before you answer. I'd asked her, what do you think you can do differently if she got it wrong? I saw her spend more time slowing down and looking over the graphic. I hope she realizes that she needs to take time. We had several teachers and students who really talked about slowing down is actually more efficient for you. 5th grade male Braille reader shared, I learned to scan left to right and look at every detail. I learned that you have to follow lines to find things. It taught me to pay attention to everything on the paper. And that's what we really want to establish for our students, is that recognition of I really need to look around. Let's talk about our second strategy, which is using surrounding information. So we really want to encourage our Braille reader to look at the text. What is it asking me? What information is being told to me? And make sure that they really understand how to then use information, such as the key, being able to compare the different textures, understanding initially how that graph is laid out. If I know that this is a map, I know that there's going to be a key that comes before the map. We also want the Braille reader to always look for a title and use that title to help them predict information. At the same time, we want them to use the text of the question or the information around them to help them really focus in on what that graphic should contain. Let's go ahead to the next slide and talk about the last concept I get to share with you before turning it back to Dr. Ezebehezi, which is the importance of previewing. The student really needs to understand how different types of graphics are laid out. So they look for those main features. If I have a bar graph, I know that there's going to be values on either the X or the Y axis, and there's going to be labels on the other axis. We don't want the student to overdo previewing, but we want them to be able to get a sense of how things are organized. And it's really important that they be able to note differences in different types of graphics. How are Venn diagrams laid out compared to box plots, for example? Oh, I get to end with a quote. So we had an 8th grader who shared, especially in coordinate planes, we have to make graphs. It is helpful to know about the X and the Y axis and which quadrants are positive and negative. General idea of previewing is good to help me in my classes. I preview now. And so this really is a learned skill for a lot of our students. They don't think to preview, and we really want to encourage that.
Our next area to look at for effective strategies is verifying information. So students that were most effective and things that we integrated into curriculum included using the Think Aloud, as well as self-regulated learning strategies to build that metacognition so that students can realize when maybe they're reading the wrong number because their hand dropped and it doesn't make sense, their answer. And also learning to compare their answer to the choices, as well as check their accuracy of their technical skills, such as tracing lines to follow a road intersection or following a guideline to the y-axis. Did they do that accurately? And they verified that by rechecking. In the area of differentiated hand movements, what we found from our analyses of looking at the videos and the hand movements is that best graphic readers use both hands to some extent. So they're using both hands to read the Braille, and they're using both hands in some way on the graphics. Good graphics readers also didn't always have things in common in terms of the strategies they use for different things, but they engaged their strategies with precision, and they checked and rechecked to make sure that they were accurate. The way their hands move and explore depended on the task of the graphic, which we saw in the video of the student checking bars and then moving across to look at the y-axis. She did different things with her hands at different times. And some of the things they may do that have been effective is using one hand to hold their place when going back to read the keys. They don't have to start over to find a spot. Noting through their exploration a quadrant or specific spot that can help them get back on track to where they are, and they can relate information on the graphic or the map to that spot. Or using differentiated movements with each hand to make comparisons. So for example, in the video, making comparisons between the heights of the bars. Some quotes related to this include, hearing myself talking about the graph out loud made me focus and think about what I am doing. So this is more about the Think Aloud process, going back to verifying information and using their metacognition. And then start at the key and familiarize yourself with the symbols, and then do a light scan to orientate myself. And then after that, go back in and look for specific things. So this is a student who, after using the curriculum, was able to really articulate a plan that we talked about in the strategies, as well as a systematic way to go about doing the exploration. And finally, we wanted to share with you something about vocabulary development. While it's not specifically related to how they move their hands across the page or gather the information, the understanding the vocabulary that goes with the different graphics is crucial for efficiency. So the ability to connect terms to parts of the graph being explored, the x-axis, the coordinate plane, as well as having that vocabulary knowledge to provide insight into what the graphic layout will be. So if they know the term coordinate plane and they've linked that to what the graphic looks like, they know what to kind of expect. They know what kind of systematic search to employ for that particular graphic. So it's a coordinate plane, so there should be two lines crossing as the X and Y axis. For example, a student would maybe say to himself, knowing that term. Some quotes related include, "Now I feel more successful in the math class because I can do math more fluently. I can work with graphs more fluently. I think if I had gone in math class before with a bar graph, I wouldn't know what to do. And now I really can see the difference." And then a 7th grade male student who's a print reader, but related, didn't know about box plots, but now I know about them and the quartiles and stuff. And so students using the curriculum gained some vocabulary development, and they noted that this was helping them in their classes. So in conclusion, just some take-home points for teachers and students with visual impairments when working with your students on developing graphic literacy skills. It's important to expose students to different types of questioning in order to guide them in building their critical thinking skills. The curriculum in Study 2 really tried to get students to answer some open-ended questions and show their thinking. And this was often very new to some students and challenging until they practice it throughout the units. Provide practice early with different graphic types to build accuracy and efficiency before they need to use information from graphs in complex ways. So in Study 1, some of the differences between a lower performing student and a higher performing student on the tasks was actually the precision. It wasn't always that the student didn't know what to do with their hands or didn't know how to explore it, but they hadn't practiced enough to be precise. And so they were making errors that got in the way of them showing what they actually knew. Expose students to the same type of graphic using different production methods. So different production methods are going to feel different, going to be laid out different, maybe easier or harder for some students to interpret. So they really should have exposure across the board, because when they get into things like standardized tests, they're going to have to deal with whatever production method has been used to create those. And then work closely with the general education teacher for consistency. This is particularly important for things like the vocabulary. If you're working with a student using the same vocabulary that they're going to encounter in the general ed classroom, will be helpful for them. And we also found throughout the studies it's important to have students make graphs to better understand the parts. There was some indication that students who had this experience were more fluent in terms of what makes up different graph types. So that's all we have for you today with the time we were allotted. So thank you very much for listening to our presentation. And should you want more details about our data and our findings, there's lots of research articles coming out or already present for you to find, most of them in the Journal of Visual Impairment and Blindness. So you can go explore extra details. Thank you very much.